Hi everyone, this is Tila here from My Teacher Lab. So in this video session, I've compiled a PDF file with the topical questions for Additional Mathematics IGCSE grade. So there are a total of 7 questions. Please feel free to download the PDF file, which I will include the link in the description, and make use of it for your classes. Or for students, please make use of it as a revision form. So the function f is defined by fx 2x plus 1 square minus 3 for a domain of x more than negative half. So for the question number 1, find the range of f. So how do we look at range in this case? Now the first step that you need to think about when it comes to range is that you need to think about what's the maximum value of y that you can get, and what's the minimum value, So what's the minimum value of y that you can get? Okay. Now, in this particular case, notice that everything that is inside this bracket will always be positive, and the outside value is a negative value. So let's just put a 0 in this case as the value for x, and you'll end up with fx equivalent to negative 3. Now this can be considered as your minimum value. Now the reason being is that if I were to draw this graph, it will look something like this. It's a simple sketch of the graph. It will look something like this. So this is a quadratic graph, which means it has a positive smiley since the coefficient is positive, and the value at which x equals to 0 will give me a negative value, so negative 3. Now notice that this is the minimum value and everything else is positive infinity, so it's going to positive infinity and positive infinity. So that's your range. So if I were to write down the answer, all I need to do is to write down fx is more than equivalent to negative 3. So that's your answer. Now what about question number 2? So expression for f inverse of x. So let me do that here. So given that fx is equivalent to 2x plus 1 square minus 3. So we are looking to find an f inverse of this function. So step number 1, let this equivalent to y. 3 equivalent to y. So that's step number 1. So step number 2 is to make x as the subject. So this means that we have to start rearranging the value, the numbers that we have accordingly to make x as a subject. So let's start. So 2x plus 1 square equals to y plus 3. Now to remove the square, all you need to do is to square root the other side. So you'll get y plus 3. And then move the 1 to the other side, y plus 3 minus 1. Now you have to make sure that the 1 that you bring it to the right hand side, it must always be outside of the square root. So do not put the negative 1 inside the square root. That would be wrong. So the final part, x equivalent to y plus 3 minus 1 over the entire thing divided by 2. Now we are almost done, except the final notation on how you write it. So since this is a function of f, therefore we would write f inverse of x square root x plus 3 minus 1 over 2. So that's the answer. So notice that I've switched the y inside on the right hand side to the x. So if there are any other y's inside, so all you need to do is just switch it to x. Alright, so now let's look at question number 3. So question number 3 involves composite functions, given that there is another function called gx. So what are you trying to do is that here you're trying to find the value of x, not just the composite function, but the value of x when the composite function f(gx) equivalent to 13. So first step, you can do it concurrently or you can do it separately. So what I'm going to do is that I'm going to try and make this concurrently. So let's do fgx. So fgx is equivalent to 13. So on the left hand side, I'm going to find my composite function. So I'm going to start with f. When it comes to composite function, always start with the inside of the function first. So the function inside is gx. So I'm going to put a square bracket like this and substitute 3 over 1 plus x. So this is the function gx. So this is equivalent to, the entire thing is equivalent to 13. Now, the next step is to substitute the f function. So as we know earlier at the top, the f function is given as fx is equivalent to 2x plus 1 to the power of 2 minus 3. So we're going to take that and put it over here. So how do we do that? The first step is to identify the x. So I'm going to change x into a box. So I write 2x plus 1 bracket square minus 3. So notice that instead of writing the x, I switched it to a box. Now this box should have the same value that I had it here. So 3 over 1 plus x. So effectively, gx is becoming the x for the function f. So I put that, fill that up, 3, 1 plus x, and there you go. Now the next step is basically to simplify this. So remember that this is still equivalent to 13. So I'm going to simplify the inside of the box. So 2 times 3, I get a 6, 1 plus x plus 1 and a square. So negative 3 move the other side, it becomes 16. Alright, so the next step is of course to remove the power. 6, 1 plus x plus 1 equivalent to square root of 16. 6, 1 plus x plus 1 equals to 4. So I'm gonna do step by step just so that you can actually follow if you are having any issues at all. 6, 1 plus x equivalent to 3, bringing the 1 over the other side. 1 plus x equals to 6 divided by 3. So notice that in algebraic equations, you can actually take the top and bring it over here. The next step is x, 6 divided by 3 is 2, 2 minus 1 is 1. So your final answer here is just 1. So that's it. So that solves all the 3 parts of the first question. So let's move on to question number 2. So this question involves a bit of sketching. Let me just change color a little bit. So sketching the graph of a modulus function 3x plus 9 for the domain that is given -5 to 2. Show the coordinates of the points where the graph meets the x-axis. There's 3 marks given to you. This is not too difficult of a question. Always remember and recall that when there is a modulus function, your graph shape usually looks like this for a linear function. Okay. All right. So let's get into it. So the first step is you can either do a tabulation or you can do a very simple linear graph and then you reflect it forward. But for this, since this is just a simple sketch, all I'm going to do is that I just put a x and a y, and then since it's a linear function, I only need 2 values. So let me just start with x equals to 0 to find the y-axis intersection, and I'll get 9, just substitution basically. And then if I want to find the other side, so if I let y equals to 0, I'll get the intersection at x, which should give you -3. So basically just substitute here and then try to solve. All right, so once you have that, you're pretty much ready to go to draw that graph. Okay, so draw your axis two main axes. Remember that this is a modulus function, therefore you need to have a positive side. You don't really need to have that negative side. So x and y are basics. Now, so the point 0, 9 is somewhere here, all right, and then the point -3, 0 should be somewhere here. Okay, so the next step is basically just to draw a straight line. All right, it's a bit difficult for me to match it, so it actually has to go through the lines. So the next thing that you actually see is that you need to write the coordinates of the points where the graph meets the axis. There are two parts where it meets the axis, so this one and this one. So the coordinate for this is -3, 0. Whereas the coordinate for this is 0 and 9. So that's it. That once you have done this, you should be able to get all the 3 marks. Now, if you forget the coordinates and you just put there 9 and a -3, you may not get the full marks. Okay, so the second question is basically a follow-up of the first question. So it says, on the same diagram, sketch the graph of y equivalent to y equals to x plus 6. So again, x plus 6 is a linear graph. So what I can do is that I can do another table, x, y, not really a table, but just a simple coordinate system. And then I can choose to use two numbers. So in this case, I just choose 0. So I put, if I have an x equals to 0, I get y equals to 6. All right. And I can just roughly plot that point somewhere. So 0, 6 should give me 0, probably somewhere around here. All right. Now remember that the domain is from -5 to 2, which means that this last number should be 2 because the graph ends here. And just extend it a little bit here. Right. So the point here should be -5. So make sure that when you substitute the x values here, you do not get out of bounds. Okay. So the other value that I can put is probably, since this is -3, let me just try -5. Okay, so -5. So I put it inside here. -5 plus 6 gives me 1. All right. So -5 and 1. So the new coordinate is somewhere here. Probably slightly lower, but that's okay. Okay, you probably would do a better job at me with the lines. I'm just winging it here. Okay, so you should be able to get something like this. So this is your y equals to x plus 6. All right, that solves question number 2. Let's go to question number 3. So question 3. Let's start with the first step, just writing down the equations. 3x plus 9 equals to x plus 6. Now, whenever you have a modulus function and you want to break the modulus function, you must remember that there are two parts of a modulus function. One is the positive side and the other one is the negative side. So let's break it into two parts. So you have 3x plus 9 equivalent to x plus 6, right? And then you have 3x plus 9 equals to negative x plus 6. So again, as a reminder, every time you break open a modulus function, you always have two sides. So one is the positive side and one is the negative side. So the reason is because either positive or negative inside here will always give you a positive value outside. So I'll just do this very quickly. So 2x equals to 3, x equals to negative, should be negative here, negative 1.5. So what about this? So for this, please make sure that you open up the bracket properly first with the right sign. So negative x minus 6. Then you solve it like usual. You should be able to get x equivalent to negative 15 over 4, or in decimals you can choose to write 3.75 negative. So that's the answer. That's it. Question 2 is done. Okay, let's move on to question number 3. Now this question is a bit complicated. Not to say complicated, but it gives you a lot of marks. Notice that it's a total of 5, 7, 8, 9, 10 marks for functions. Write down the range of f. So you're given fx equals to x squared plus 1 over here. And they're asking you for a range. Now, when it comes to range, as I mentioned earlier in the previous question, you have to find your minimum value. At the very least, you find the minimum value. In this case, it's quite easy to see that your minimum value is 1. Now, how can I be so sure that the minimum value is 1? Notice that the graph of this function, if you were to sketch it, will look something like this. So it will look something like this. All right. So your graph is always lifted 1 above the x-axis. So this is 1. Therefore, that's your minimum value, and everything else will be infinity and infinity. Therefore, your range should be written like this. So fx more than equals to 1. All right. Now, the next part is to find the value of gf3. So this is a composite function, but you do not have to necessarily find the entire composite gfx first. There's a simple way to do this. So let's look at that. So let's start with gf3. Now, first step is to do the substitution of the f3. So f3 will give me this. So this is the fx function. So change the x to 3 right away. So you can write 3 squared plus 1. So that will give me g and a 10 inside, right? 3 squared 9 plus 1, 10. Now you only are left with g10. So instead of trying to find gfx, which can be tedious and a longer procedure, so you can just straight away substitute the values inside. So g10, what's g10? Substitute 2 x equivalent to 10 minus 5. So immediately you'll get 20 minus 5, and the answer is 15. And that's it. All right. So question number 3 involves solving the equation for a composite function with an inverse function. This means that we have to find the fgx first, and then find the inverse function with a 15 inside before we start solving this question. So step 1, I'm going to find my inverse first. So I'm going to find my g inverse 15. What would be the value for this? So the function is given as 2x minus 5. So let me find the inverse. So let 2x minus 5 equals to y, 2x equals to y plus 5, x equals to y plus 5 divided by 2. Therefore, my g inverse should be written as x plus 5 over 2. Okay, so what if I substitute my 15 inside? So it will give me 15 plus 5 divided by 2. That should be about 10. All right, so I've got that part done. So the next part is trying to find the fgx. So fgx, okay, which is now equivalent to 10. Right, so why 10? Because g inverse of 15 is now 10, so I equate it to 10. Now, fx is given as x squared plus 1, all right, and gx is 2x minus 5. So let's start again from the inside. So f, substitute the gx inside this box, 2x minus 5, then keep the 10. So substitute f. So f should be x squared plus 1. So treat x as a box. So x squared plus 1. Okay, keep the 10. So whatever that is inside the box, you bring it back here. Alright, so to continue, all you need to do is that you need to rewrite this in this form and get this to be 9. So 10 minus 1, 9. Now, you do not have to necessarily expand this because there's a simpler way, which means that I can square root both sides. So when I square root both sides, I get square root of 9 is equivalent to 3. Alright, so I solve for x. So x should be equivalent to 8 divided by 2, 4. Alright, now I made one clear error here, is that I did not show plus minus. So whenever you square root a number, I should always get a plus and minus the value, which is in this case 3. So let me show you the other side. So 2x minus 5 should also be negative 3. So there are two answers. So make sure that you do not forget that. So next step for this, just simplify. You should be able to get x equals to 1. So you have two answers for your x. Alright. Now, whenever you have solutions like this and you have a long question, please refer back to your original definition of the function. In this case, the definition for the domain says x is all real numbers, which means that both x equals to 4 and x equals to 1 falls in that range. So both answers are acceptable. Now, let's say if the question says x cannot be 4 or something equivalent to this. So you cannot accept this answer even though after your calculations you get that answer. Question number 4. Let's see. On the same axis, sketch the graph of y equals to hx. So hx is this guy, right? And the graph of the inverse function y equals to h inverse x, indicating clearly which graph represents h and which graph represents h inverse. So first thing is, you are required to draw this graph and then the h inverse of the graph. Now, in this case, you do not have to necessarily go and find the h inverse function because you're just sketching a graph. So let me show you. It's quite easy to draw this particular graph because every exponential graph has a similar shape. So the shape would look something like this. All right. So okay, it's a little bit bad. Let me just draw it properly over here. Okay. Okay, please label your axis. Sometimes I forget to label my axis, but yeah. So just use a different color here. So your 2 to the power of x should have a graph like that. Okay, this is going down and down towards the x-axis, and this is going up to infinity. Now, what is the value here? So if you notice, if I put the value here, at the center here, it will give me x equals to 0. So 2 to the power of 0 is 1, which means that this value is always 1. The y-intercept basically. So this is already the function hx. Now how do I draw the h inverse function? So you need to first understand the concept of the inverse functions. Inverse functions are basically reflections. Okay, so inverse function is a reflection of the original function at y equals to x. So y equals to x is a line that passes through directly proportionally through the coordinates 0, 0. So that's y equals to x. So how do you think this will be reflected on this side over y equals to x? So let me choose a different color, in this case probably a green color. Okay, so it'll be reflected like this. So instead of the x-axis, it will go from the x-axis like that. Okay, my graph is not always perfect. I have problems with drawing So the best I can draw is like a stick figure. Please label your graphs h inverse of x. So if you do not label, you may not get the marks that you're supposed to get. Sketch the graph of this, showing the coordinates of the points where the graph meets the axis. So note that this question is quite similar to the question that we did earlier on sketching the graph. So I'm going to try to do this quite quickly. Just remember your domain as usual. So I'm going to put up the coordinate system, coordinate table. If I substitute 0, I get a 5. If I substitute 0, I get a 5/3. Should be a positive value. Okay, if you don't know what to do, please just substitute the values inside here and then you get this too. So why am I using x equals to 0 and y equals to 0? That's because when x equals to 0, I get the y-intercept, and when y equals to 0, I get the x-intercept. Okay, so when x equals to 0, I get a 5, so maybe somewhere around here. That's a 5. And then when x equals to 5/3, which is slightly more than 1, and less than 2, should be somewhere around here. It's really up to you, by the way. You just need to draw a straight line, okay, and then reflect it. So that's it. So a modulus function, as I mentioned earlier, will always have that V shape if it's a linear function. Okay, so also note that this should be your -2, and the last value, you should extend the axis, but never mind, should be around 3. Okay, so please follow these two values. It's always good to label them. Now again, they're asking you to write down the coordinates, which I haven't written here yet. So instead of just writing 5 and 5/3, you might as well write the coordinate system itself. Okay, so in this case, this is 0 and 5. This is 5/3 and 0. And that's it, 3 marks. Draw on the same diagram another graph of y equals to 8x. If I had an x and a y, if I put a 0 here, I will also get a 0. Now, since this is just a sketch, so you don't have to be extremely accurate, you just need to make sure that the gradient of this graph is slightly steeper than this graph. So basically I can draw something like that. Okay, if you want to make it a bit more steeper, that's fine. Okay, so this is y equals to 8x. So finally, the last part of the question asks you to solve this equation. So let's start with this. 3x minus 5 equals to 8x. Remember, modulus function will always give you two sides. So let me separate that into two different sides. So 3x minus 5 for the positive side, and 3x minus 5 equals to negative 8x for the negative side. Now let's open this up and solve it. So in this case, you get x equals to -1 after you simplify everything. And from this side, you should be able to get x equals to 5/11. Let me double check that. -8, +11. Yep, that should be correct. Okay, once you got these two answers, you may think that everything is fine and nothing is wrong. Okay, now there's a short problem here. So one of these answers are not right. So the easiest way to check it is to try and do some substitutions. Now, I can clearly automatically say that this is wrong, and I'll give you a reason why. So notice that on the right hand side, you have 8x, correct? So if I were to substitute the x inside here, I'll end up with a negative value. So I get 3 -1 minus 5 equals to -8. So try and solve the thing inside the modulus. So you get 3 minus 5, -3 minus 5. So that's -8. So supposedly everything inside the modulus should be a positive value, correct? So in this case, there is a negative value. So that means that this is not an acceptable answer. So not acceptable. Okay, so please always double check, especially when you have a modulus or if you have any other functions with a specific domain. So please double check. Okay, let's try question number 5. So you're given a function for all real numbers of x, and then you have x squared plus 4x minus 6. So let's see. Find the least value of fx and the value of x for which it occurs. What is the minimum value? Okay. And when can we get the minimum value? So how to do this? So the easiest way to do this, let me just show you here, is this. So you need to know that there's a technique where you can find the minimum value of a quadratic function quite easily. So what do? We just equate x equals to negative b over 2a. Now, you may ask me why this. A quadratic equation or quadratic function has a graph shape like this. Okay, so it's symmetrical, right? So when it's symmetrical, what this formula actually does is that it finds you the equation of symmetry. So equation of symmetry means all I'm doing is that I'm trying to cut this graph into half. So my x value is always at the middle of the graph if I were to use this particular formula. Okay, so I will not go into details on how you derive this formula, but once you do chapter on quadratic equation, you should be able to find out how. So anyway, let's just find out the minimum value. So we know that the value would be minimum because this is a positive graph. So a positive graph will always have this shape, and therefore you will only find the minimum value. Maximum value is infinity. Let me find what is a and what is b. So a equals to coefficient of x squared, which is 1. b equals to coefficient of x, which is 4. Substitute into this equation. So you end up with x equals to negative 4 over 2 times 1. This is negative 2. Okay, so at x equals to negative 2, so at x equals to negative 2, you will get the minimum value. Minimum value equals to, substitute the negative 2 inside fx. F negative 2 equals to negative 2 squared plus 4 negative 2 minus 6. So you should be able to get negative 10. Okay, so your minimum value here should be negative 10. So if you look at this, this is the mark scheme for IGCSE papers. So if you're given 2 marks, just understand that if you're spending more than 2 minutes, that means you're not going to have enough time to finish your paper. So if it says one mark, just try to spend about 1 minute to finish up that question. Now let's go on to the next part. Hence, write down a suitable domain for fx in order that f inverse x exists. Now this is a fun question. So if you're not very clear about how inverse function works and what's the notion behind f inverse or any inverse function at all, you will not be able to answer this question. Okay, so I will go through this a little bit more in detail. So let's just think of inverse functions as a copy of a function at y equals to x reflection, as I mentioned earlier. Now for this reflection to exist, you need to always have a 1-to-1 function, which means for every x there's always a unique y, and for every y there's always a unique x. We can test this by using the horizontal line test. How does that work? Let's say I have a graph. Okay, a graph like this. Let me do the horizontal line test. So I take a horizontal line on any point of this graph. Okay, notice that there are 2 intersections. All right, so when you have 2 intersections, that means that for the value of, let's say, negative something, and positive something, there are two y values that are similar. So which means it's no longer unique. That means this is not a one-to-one function. How do we make sure we can still find a suitable domain for fx, which is this drawing here, in order that f inverse exists? All we need to do is to either destroy the left-hand side or the right-hand side of the graph. So instead of the full graph, I can start with the domain like this. I will draw another set of graph which kind of more similarly represent the function that we are talking about right here. So it will look something like this, in which the curve is more towards the negative side, -2. Okay, I'm just going to ignore the left-hand side of the graph. Okay, so if I ignore the left-hand side of the graph, my domain basically starts from -2 up until here, right? So I can say that my domain is x more than -2. So when that happens, when x is more than -2, I will be erasing this entire part of the graph. So I'll just use a dotted line to imagine that full graph. Okay, so this means that if I were to draw a vertical line test, I only have one intersection, one intersection, one intersection. So this ends up becoming a one-to-one function, which means I can say that this one has an inverse function. Now, similarly, you can also use the other side of the function. That's fine. There are more than one answers for this. So there can be other domains. You can even use a shorter domain. You don't even have to start at -2. You can start here to here. That's fine. But preferably, we always take the positive side that starts at axis of symmetry. So we split it into half, take one side, and that's it. So the domain is x more than -2, starts from here up to here. All right, so the next question, question number 1, is finding the inverse of gx. So let's see gx. What's my gx? Oops, oh, the gx is here. So how do we find the inverse of this function? So let's start. X over 2 minus 1 equals to y. X over 2 equals to y plus 1. X equals to 2y plus 2. And we have our g inverse, 2x plus 2. That's quite easy. So you get 2 marks for that. Okay, what about question number 2? So you're trying to find a g composite function of x, GHX, and then you equate it to g inverse of x. So which means, let's just, since we already found the g inverse, let's try to find GHX. So GHX, again, start with the inside function. So GHX. Right. And then substitute the g. So in this case, there's an x at the top. So x over 2 minus 1. Put it back inside the box. The next step is to equate what we have here and also with what we have here. So let's equate them together and solve the function. So the first one was GHX, so let me write the GHX here. All we need to do is to simplify this one by one. So I'm going to start with x squared minus x over 2 equals 2x plus 3. Then one by one, we just bring the values to the right hand side and move the x to the left hand side. Simplify this by using factorization, so you can use a calculator or any other methods that you like. So equals to 0. I use a calculator to quickly get the value. So x equals to -1, x equals to 6. So you have 2 answers in this case. All right, so that's it over here. Let me just double check with my range if that meets the range. Yes, it meets the range. Okay, question number 6 is quite straightforward, quite simple. We have done this a couple of times earlier. So quickly, let's do the answer. So again, splits into two parts. So 2x plus 10 equals to 7. 2x plus 10 equals to negative of 7. So for the first part here, I'm going to get x equals to negative 8.5. And then here I'm going to get x equals to negative 1.5. So you have two answers. Okay, that's it. So that's 3 marks for you. I mean, of course, you have to do a bit more working, but I just want to speed things up on that side. Right, so final question, another 10 marks. So first one is quite simple. Let's begin very quickly. So FG9. So if there is already a number inside, please do not go and find out FGX first. You just need to substitute for 9. So GX is 9. So let's see. 3, 9 plus 5, 9 minus 1. Got that? So that should give you F. Simplify this, 27 plus 5, 32 divided by 8, you should get 4. Okay. So once you get F4, substitute the 4 into this. So you end up with 4 plus 1 squared minus 4. So final answer, 21. Alright, question number 2. Now that's a killer because you have to do F inverse and then find G inverse. So for F inverse, let's start with F inverse. You need to let x plus 1 square minus 4 equals to y. X plus 1 square equals to y plus 4. Square root the other side. Y plus 4. And then x equals to square root y plus 4 minus 1. Okay, do not forget to convert this back into the inverse, equals to x plus 4 minus 1. Please do not leave your answer like this. You have to convert. Alright, so that's F inverse. What about G inverse? So for G, for G inverse, all you need to do is G inverse. You're going to take 3x plus 5 over x minus 1 equals to y. So bring everything to the other side from the bottom. So you get yx minus y, multiplication of these two. Okay, so the next step is to bring the yx over. So you get 3x minus yx, negative y minus 5. Okay, only bring the term with the x to the left hand side. Now you just factorize the x. So you end up with 3 minus y equals to negative y minus 5. And then bring over the 3 minus y again to this side. So you get 3 minus y. Okay, we are almost done. So let's change this back to G inverse x. So negative x minus 5, 3 minus x. Alright, now one thing about this type of form is that we usually prefer to leave this in a positive form. So I would like to multiply this by negative 1. So sometimes you see this happening. In the marking schemes, you will see this. So your answers may not exactly look alike. So you can do this. So multiply, you will end up with positive. So you end up with x plus 5 and then x minus 3 instead. Okay, so it's the same. So no difference. Alright, that's the final question. So find the value of x for which gx equals to g inverse x. So which means that I'm going to take gx equals to this guy. Okay, so let's try that. What do is that we do cross multiplication. So when we do cross multiplication, we multiply this side, this to this, and this to this. Okay, so let's do that. So we write 3x plus 5 x minus 3 equals to x plus 5 x minus 1. Right, that looks fairly simple, but you know that this is a bit more complicated because you have a lot of expansion to do. Okay, Be slow and steady and do not expand too fast or too quickly. But once you have done the proper expansion, you should be able to get 3x squared negative 4x negative 15 on the left hand side, and on the right hand side you should be able to get x squared plus 4x minus 5. 2x squared negative 4x minus 4x, you're left with negative 8x. Negative 15, bring the negative 5 over this side, you will end up with negative 10. So you can do this step by step. I do not want to prolong, so I'm just going to simplify this. Okay, now before you factorize, you may want to simplify this. So every term can be divided by 2. So I can also write this as x squared 4x minus 5 equals to 0. So once you simplify, it's easier for you to factorize if you are using manual method of factorization. So once you factorize, you get x plus 1, x minus 5 equals to 0. Alright, so that means this is x negative 1 and this is x equals to 5. So there are two solutions here, but as usual, please go back and check whether this meets your domain requirement. So go back up. Remember that your domain, I highlighted here that it has to be x more than 1. That shows that one of our answers does not fit within the domain. So this one does not. This one, yes. So just give a simple conclusion, say not within domain. All right. So that's it. So we have done 7 different questions for the topic functions. So all of this question were based from past year question for IGCSE. So this gives you a better picture of the difficulty of the questions. So I hope that this video has helped. So if you enjoyed the video, please click like and subscribe to the channel.